Greetings to dear students. As we have discussed the properties of various types of substances, pure as well as impure substances, along with the properties some of these show, next we will see about saturated solution. Saturated solution is a solution which cannot dissolve any more amount of a solute at a given temperature. Thus, it explains about solubility. Solubility of a substance is the amount of solute present in a saturated solution of the substance. Unsaturated solution, whereas, is a solution which can dissolve some more amount of solute in a given temperature. Like for example, if we consider 50 ml of water in 2 beakers, add salt in 1 beaker with continuous stirring till no more salt dissolves in it. Similarly, add sugar in the other beaker with continuous stirring till no more sugar dissolves in it. We get saturated solutions of salt and sugar at the specific given temperature. If the mixtures are heated, it dissolves more amount of solute in it. Thus, it results in the preparation of supersaturated solution, which on cooling gives the crystals of solute back. The solubility of different substances are different, and solubility of substances vary with temperature. To this, the concentration of a solution which differ can be considered as the amount of solute present in the given amount of the solvent or solution. It can be calculated by amount of solute divided by amount of solvent, or amount of solute divided by amount of solution. Whereas the concentration of a solution can be expressed as mass by mass percentage or mass by volume percentage too. Mass by mass percentage of a solution can be calculated by mass of solute divided by mass of solution into 100, and mass by volume percentage of a solution can be calculated by mass of solute divided by volume of solution into 100. Based on the concentration of a solution and concentration of a solution by mass percentage or by mass by volume percentage, we have discussed with different numericals. Kindly go through the numericals, revise the numericals for this. Now, as we said, the mixtures do have different components of pure substances added in any ratio. We can get the components back too. The method to be used for separating a mixture depends on the nature of its constituents. The various processes used to separate constituent of the mixture are filtration, evaporation, sublimation, centrifugation, chromatography, distillation, fractional distillation, crystallization, and manual methods like, for example, hand picking, magnetic separation, sieving, threshing, winnowing, etc. By these, we can separate the non-volatile components from its volatile solvent, insoluble components from their soluble subpart, different components involved in the particular mixture, and have specific techniques to be used for the separation of components of a mixture. Separation methods therefore do have if considered to be chromatography, what it separates: compounds or components in a solution with same properties, that is, dissolve in the same solvent. It is the technique used for the separation of those solutes dissolved in the same solvent with the help of a strip of a filter paper, therefore also known as paper chromatography. Second, filtration. It separates solids, a group of solids, and liquids in a mixture. These solids are usually the insoluble components of the mixture. Third, magnetic attraction. It separates magnetic substances from non-magnetic ones. Fourth, crystallization. Dissolved solids in a solution can be separated to its pure form. It is a process that separates a pure solid in the form of its crystals from a solution. Fifth, simple distillation or distillation. It separates liquids of a solution. Usually, if the liquids in a mixture are miscible, boil without decomposition, and possesses different boiling points, then these can be separated by distillation. It is used only when the liquids have a difference in boiling point of more than 25 Kelvin temperature. But if the difference in the boiling point is less than 25 Kelvin, we use fractional distillation. The next, separating funnel. It is based upon the principle that immiscible liquids separate out in layers depending on their densities. The next, sublimation. Substances that sublime from two substances or two or more components can be separated by this method. The solids which on heating do not enter to liquid phase but directly converts to the gaseous state is actually possesses sublimation or as sublimates. This, when cooled down, the vapors of the sublimate can be removed from the mixture. Evaporation. Solids that cannot decompose when heated in a solution is separated by evaporation method. It can be used to separate a volatile component, that is solvent, from a non-volatile component, that is solute of a mixture. Similar to it, when we consider hand picking, it actually separates the components which differ in shape, size, color, etc. If we consider threshing, we can separate the components on the basis of the machine thresher being used. Winnowing is to separate the components which are of lighter in weight, can be pass away or removed by wind. Sieving, on the other hand, is like filtration, which separate the solid insoluble components from the mixture. So when we consider these methods are the physical methods. The physical methods are the part of physical changes. In physical changes, only physical properties of the substance change, whereas the chemical properties remain as it is. So we can get the components of the mixture back. Opposite to physical changes are the chemical changes, where one substance reacts with another substance to undergo a change in a chemical composition and a new product is formed. So we have discussed in lesson about pure and impure substances with the various properties to it. Thank you.